Yep, here you go. Okay guys, this is the fourth question. uh, let me describe the fourth question. What it says. So here we have a car. This is the fourth question. Here we have a car, starts with a velocity of 2 meters per second and continues to accelerate at 1 meter per second square for 6 seconds. Then it moves with a constant velocity in the same direction for 10 seconds and finally goes to rest after 4 seconds. So okay, so what are the requirements? Find the velocity at 7th second, find the time of deceleration, find the total distance covered. Okay, all right. So to solve this question, we have to divide the scenario into 3 parts. Okay, the first scenario would be a car starts with a velocity 2 meters per second and continues to accelerate at 1 meter per second square for 6 seconds. So this is the first scenario or first event. So it accelerates for 1 meter for 6 seconds at 1 meter per second square with an acceleration, and the initial velocity of this event is given, which is 2 meter per second. Okay, then it moves with a constant velocity in the same direction for 10 seconds. That means that we have the event 2. Here the velocity is constant, the velocity of the whole event remains constant, and the time of the event 2 is 10 more seconds. That means that the total time is 6 plus 10, 16 seconds at the end of event 2. Okay, now we have the event 3, and what the event 3 says is and finally it goes to rest after 4 seconds. So that means the car is decelerating and it goes to rest. The final velocity of this event is 0. For this event is 0, and the time of this event is 4. Remember, treat each event as different event. You cannot intermix the data of each event. You will deal each event separately and then you will combine everything. So to better understand the problem, let's draw the velocity time graph for this problem, and which will tell us that how our velocity varies with time. We will do a rough sketch, not a good sketch, just a rough sketch to know how things are working. Okay, so let's see. For the event 1, we have initial velocity as 2 meter per second. That means that for time 0, for the t is equal to 0, we have a velocity of 2 meter per second. Okay, and then it says that it accelerates. That means the velocity will increase with time. Okay, so the velocity increases with time. For the first second, the velocity would be 2.1, 2 point something, 2.8 or 2.9, but we will know. For the second, it will be 3 point something, and for the 6th second, it will be something we don't know. Okay, all right. So this is the event 1. This is event 1. The event 1 is from 0 to 6th second. Okay, and the velocity c is increasing with time. Okay, for the first second you go and you find the velocity to be greater than 2. For the second second you go and then you find the velocity to be greater than 2, and so on. Okay, this is the first event. In the second event, it says that the velocity is constant for another 10 second. Another 10 second means from 6th second to 16th second, the velocity will remain same, and the time interval between these two is 10 seconds. So from here to here, the velocity will not change. Okay, so that's why the velocity is same at each point, right? And for event 3, the velocity is decreasing, right? The velocity is decreasing, and it says that the car goes to rest after 4 seconds. After 4 seconds means that 16 plus 4, 20. At the 20th second, the car goes to rest here. Okay, notice that the final velocity of event 1 is the initial velocity of event 2, and the initial and final velocity of event 2 is the initial velocity of event 3. This you have to take into account. Now we will go into event 1 and see what we can find. For event 1, we have initial velocity as 2 meter per second. The time of the whole event is 6 seconds, and the final velocity of the event we don't know, which is the velocity at 6th second. Okay, velocity at 6th second, which is this velocity, is the final velocity for the event 1. So let's see what are the requirements, what we have to find. It says to find the velocity at 7th second. Okay, find the velocity at 7th second means that we have to find the velocity at 7th second. So the event 1 is for 6 seconds, right? And the event 2 is of 10 seconds. The 7th second would lie in the event 2. Okay, the 7th second would be in the event 2. That means we have to find the velocity for this question in the event 2. And notice the amazing thing about event 2, that each time the velocity remains constant. Okay, from 6th to 16th second, the velocity does not change. That means that the 7th second, at the 7th second, the velocity is same as the velocity at 6th second. And the 6th second velocity is the final velocity of event 1. Okay, so if we are able to find the velocity for event final velocity of event 1, we would be able to find the velocity for at 7th second. So we have vi, we have t, we have acceleration a, which is 1 meter per second square. Okay, so we have to find vf, and vf for this event. So vf is equal to vi plus at. This means that we have velocity 2, a is 1, and time is 6. So we get a velocity of 8 meter per second. This is the velocity at 6th second. Okay, velocity at 6th second is 8 meter per second, which is also equal to velocity at 7th second, because velocity at 6th second to velocity at 16th second remains constant. Okay, so we have the answer for the first part. Now find the time of deceleration. Okay, time of deceleration is, this is part 1. Now we go for part 2. Part 2 says find the time of deceleration. Okay, we don't need to have calculations in this part, because we already know that the deceleration take place in the event 3, and the time for time taken for the car to decelerate is 20 minus 16, which is 4 seconds. So time of deceleration is 4 seconds. Okay, now And the final part is part 3, which is find the total distance covered. Okay, find the total distance covered. Alright, there are two ways to solve this problem. One way is to solve it graphically, the other way is to use the equations. We will use the equations. We will not go into the graphical method because we haven't introduced it, but anyways, we will see how we can solve this problem. Anyways, okay, so we will find distance for each event, event 1, event 2 and event 3, and then we will sum up all the distances. For event 1, okay, known quantities, now we have Vf because Vf is given. For event 1 we have Vf is equal to 8 meter per second, Vi is equal to 2 meter per second, t is equal to 6 second, acceleration is also given, which is 1 meter per second square. Now we have to find s. Okay, I think we have all the quantities available, so the I will go with the s is equal to vit plus half a t square. Okay, so vi is 2, t is 6 plus half a 1, t square is 6 square, which gives me 12 plus 18, okay, it's 36 divided by 2, which is 18, and this gives me I think it's 30, is 30 meters. Okay, we can also use this equation, 2as is equal to vf square minus vi square. So s is equal to vf square minus vi square divided by 2a, and let's see if the answers are consistent. 8 square minus 2 square divided by 2a, which is 1. This gives me 64 minus 4 divided by 2. This is 60. 60 divided by 2 is 30. So this and this value is same. That means these equations are making sense. Okay, the equations are making sense. This is the distance for the event 1. We will find the distance for event 2 from here to here. For the event 2, we have v constant. Okay, v because see, the final velocity of event 1 is the initial velocity of event 2. So vi for the event 2 is 8 meter per second. Okay, vf is also 8 meter per second. Okay, and okay, okay, all right, and acceleration is 0 because the velocity is not changing. All right, we will see that how we can reduce this equation of non-zero acceleration into the case where we have only uniform velocity or constant velocity, taking into account s is equal to vit plus half at square. Okay, so since acceleration is 0, this whole term gets 0, so only the formula we have is vit. So vi is actually vf, so we can simply say it's vt, right? S is equal to vt. So we will, for the event 2, our v is 8 meter per second, and the time of the event, we don't have to use the whole time, we have to use the specific time from 6th to 16th second, which is time of the event is 10 second. Okay, So the total S is 8 multiplied by 10, which is 80 meters. Okay, this is S, this is S1 for the event 1, and this is S2 for the event 2. Now we will find the S for the event 3. Okay, alright, I hope it's easier for event 3. Okay, now for the event 3, that okay, for the event 3, make sure that the final velocity of event 2, okay, the final velocity of event 2 is actually the initial velocity for the event 3. So vi of the event 3 is 8 meter per second. Vf of the event 3 is 0 because the car goes to rest, and the time of the event is 4 seconds. Okay, we can't take 20, but we have to take the time taken for the specific event. So our event is the car is decelerating. That is our event, and the time for this event is 20 minus 16, which is 4 seconds. And now we have vi, vf, and t. We can find acceleration because we don't know the acceleration for this event. And without acceleration, remember, without acceleration we can't find the distance. So it's better to find the acceleration first. Vf minus vi divided by t. Vf is 0, vi is 4, and time is, oh sorry, vi is 8, okay, and time is 4. So minus 8 divided by 4 is minus 2 meter per second square. Okay, now we have acceleration as well. Right, kind of page. Okay, for event 3, we have vi, okay, we have vf, we have t, and we have acceleration. So we can use I should go with s is equal to vit plus half at square. You can also use the other one because it doesn't matter. Vi is 8, time is 4, okay, plus half. A is minus 2, and t is 4, okay. So 8 4 32 minus 16, which gives me 16 meters. Now the total distance covered is, the total distance is 16 plus 80 plus 30, okay. So this gives me 96, 96 plus 30, I think it's 126 meters. 110, yeah, 126 meters. So the total distance is 126 meters. Okay, so this is the 4th question. We will go for the 5th and 6th questions in the next video. I think this question was lengthy, so see you in the next video.